Hello, friends. Welcome to my live stream. And this is Akulmach Science Show, and we would like to discuss about very interesting particle which is known as neutrino. And recently, neutrinos have been detected, and neutrino has been a very elusive particle. Very little we know about neutrinos. It has very different properties. It is different from electrons. It is different from light particle known as photons. And what is happening, what is so interesting about neutrinos that we should know? So in order to understand this, let us find out what triggered this particular video. And this is about the interesting findings made by observatory located in the Antarctica region known as ice cubes. Ice cube is literally an ice cube. It's not because of any other thing. It is actually 1 square kilometer observatory, 1 square kilometer, pretty large, deep inside the ice on the Antarctica. So there was a observation by ice cube made that there are neutrinos coming from a galaxy which is about 57 million light years away. So it's like millions of light years away, there is a galaxy which has now started to shoot neutrinos in all directions. And back here on Earth, we are able to observe this phenomena. And Ice Cube was able to detect neutrinos are coming from, such a far off distance. Well, in order to understand what is so significant about this particular discovery, we have to understand what are neutrinos. Well, neutrinos are one of the fundamental particles. In fact, these are the particles which were first created after the Big Bang along with the electron. So the difference between electron and neutrino is that the electron has a charge which is negative charge, and it has a mass. Neutrinos are nearly they are not as light as the photon, but they are very light. They are lighter than electron, and neutrinos do not have any mass whatsoever. And also neutrinos, as the name suggests, does not have any charge. And therefore neutrinos are only affected by the weak nuclear force and the gravity. So if there are neutrinos passing, in fact at this moment, billions and billions of neutrinos are passing right through our body without even doing any kind of interaction with the matter. In fact, the neutrinos are such a crazy particle that it can pass through the entire planet without touching any component of the atom throughout. It can pass through the core of the earth also without even interacting with any matter. So neutrinos are definitely very less understood fundamental particle. And neutrinos are produced by sun. Neutrinos are basically reaching earth all the time, because 24/7, day and night, earth is washed into the neutrinos which are coming from sun, because sun is a very big bright object very close by. So far we have seen neutrinos, almost 99.99% neutrinos coming from the sun. And for the very first time, this discovery has been made that there is a detection of neutrino from a far off galaxy. And therefore it is a very exciting discovery. And now we know that neutrinos could be everywhere. And our observatory is able to detect neutrino from other sources. First of all, to detect neutrino, it is very difficult. As I said, the neutrino does not interact with the matter itself, and since it does not interact with matter, our detectors will find it very difficult to detect neutrinos. So most of the neutrinos are generated from sun, which are found on earth, and they just pass through the planet and everything else which is present on the planet. In fact, neutrinos can go millions and millions of light years without interacting with anything, and they just simply, it appears as if there is nothing in their way. There is no matter, no planets, no galaxies, nothing. They just simply keep traveling, unlike their cousins, the photons, which has a mass, and the photons also have electromagnetism. The neutrinos, on the other hand, the photons do not have mass. Neutrinos have some mass, but they do not have any charge. So therefore, they do not interact with even electromagnetic. They do not even interact with the photons. So that is why they are very sort of crazy particles. And to detect neutrinos, we have to rely on indirect methods. So that is why we put our observatory, the ice cube, this is known as ice cube, deep down below in Antarctica. And it's a very huge observatory, because the chances of getting a neutrino signal is very rare. So the observatory is about 1 square kilometer in all directions, and there are very sensitive light meters put in there. The idea is that neutrino does not react with anything, especially the water, the ice particles, but neutrinos, when they're traveling in ice, will be traveling faster than light. So when I say faster than light, doesn't mean that they are going to violate the laws of the universe. Well, it is well understood that when the light, natural light or photons are passing through ice, their speed is 25% slower than the usual. So neutrinos will continue to travel at the same speed, nearly the speed of light, whereas the light will slow down. And by stroke of luck, if there is a neutrino which basically interact or collide with an atom, it will actually give out a cone of a light, which these detectors can detect. So basically, if neutrino is passing, this the light which is generated by interaction, if they collide with a particle of ice atom or something, there will be some sort of a photon release, and that is the signature that the neutrino has just passed by. Even though we are not able to measure the neutrino, but we are able to measure the path of the neutrino, and therefore that is how we can identify that there are neutrinos coming. Now, since we are able to capture their direction and we know pretty much their properties, we can then pinpoint, triangulate from where they have come. And this time it has been observed that these neutrinos have been detected very, very far from a far off source, which is millions of light years away. And this beautiful galaxy is known as NGC 1068. Well, there is nothing unique in this galaxy. It is like a typical spiral galaxy, but the very fact is that neutrinos are coming from this galaxy. That means the central black hole at the core is basically started to heat up and started to basically gobble up gases and matter. And because it is gobbling up things, the neutrinos are being generated. How? Well, when things start to fall into the black hole, central black hole, they start to rotate around in something called accretion disk. And accretion disk is pretty much like the cyclotrons the scientists use to measure these subatomic particles. But this is a natural cyclotron where all the matter, atoms, and everything else is smashed together around the black hole. And that is when the neutrinos are generated. And therefore, when the neutrinos are coming from this particular galaxy, it means that the central black hole has just started heating up. It is in the process of becoming a quasar. It started up eating the gas and attracting a lot of matter in the center of the galaxy, and that is why we are getting these neutrinos. And because we are getting these neutrinos from this galaxy, it will tell us a lot of details about the nature of this black hole. So indirectly, this discovery of understanding how neutrinos can be used to understand the surrounding around any black hole. we have got this evidence from this particular galaxy, but then based on the neutrinos which are coming from the galaxy, we can actually get some idea about the surrounding of the black hole, and then probably predict how the environment would be by around any black hole. So that is why this is very exciting. And so far neutrinos have been completely ignored because there was no way to even detect them. So now we have been able to detect them, and there are more than one observatory in the world. We can basically start something called neutrino astrophysics or neutrino astronomy, and so far our observations are based on the visible light, really the understanding of photons. But then we can also branch out astronomy and try to look at our universe from neutrinos, because neutrinos are everywhere. And if we are able to see if these neutrinos are going to tell us something more about the surrounding of universe, then it'll tell us lot many things. So I think this is an exciting beginning of exciting beginning of a new type of astrophysics, which is called neutrino astronomy, and therefore this is very exciting. So in this live stream, which is the Akulmach Science Show, I am bringing this particular discovery, which is very exciting. And if you follow the latest discoveries in our nearby space-time, this one must be quite exciting for you, because if we develop this particular aspect of understanding, measuring things using neutrinos other than light, then we will have much more deeper understanding of the space-time. So friends, if you have any questions, feel free to shoot your questions, and I will take up in tomorrow's session. Otherwise, as always, thanks for watching, and I will catch you again in the next session. Have a nice day.